Okay, so for your virtual lesson here, we're going to be looking at Chapter 5, Section 5, which is inequalities in two triangles. You can see at the end of the lesson, I can compare a pair of sides of two triangles when the remaining pairs of sides are congruent. Okay, so here's our example 1. It says, as a rider pedals a unicycle, how do the measures of angle A and the length of side B change? And what does this suggest about the change in the triangle? So when we look here, think about pedaling a unicycle. So as we pedal the pedals, the length of B is going to be getting longer. Do we see that? From the first picture to the second to the third, side B keeps changing. Now what we notice is the seat post, which is the blue line, is the same. It never changes. And the crank arm, which is what goes from the center of the tire to the pedal, it never changes, right? The only things that are changing are the angle here between the seat post and the crank arm and the length of side B. So what's happening? Well, as the angle A is increasing, the length of side B is also increasing. So that is what we're going to be investigating and working on during the lesson today. It says if two sides of a triangle stay the same, but the measure of the angle between them increases, the length of the third side must also increase. So when we look at this, I want you to try this on your own. So I'm going to read the question. Compare the measure of angle J and the side length of K for all the triangles. So you try to think through this. Pause the video. Okay, so if you look here on the acute triangle, that means all of the angles are less than 90. And then on the obtuse triangle, angle J is bigger than 90. And then on the right triangle, angle J is exactly equal to 90. So when angle J is at its smallest, that's when side K is at its smallest. And then angle J in the middle would be the right angle. And that's where that's where side length K is in the middle of the lengths. And then angle J is the largest in the obtuse triangle. So that means that side length K is the longest. So what they want you to answer is, as the measure of angle J increases, the length of K also increases as we go from acute to right to obtuse. Okay, so you're going to have quite a few problems that kind of look like this. So you can see I've got two triangles. They have two shared side lengths. You see how AC is 3 and DF is 3, and then we have AB is 2 and DE is 2. So you have a triangle with two shared side lengths. The only known difference here is we know that angle A in the first triangle is 45 degrees, whereas angle D in the second triangle is 60 degrees. So because the other two sides are the same, then the only thing that's changed is the angle. Think about where that unicycle was working. That means that side CB, which is there in blue, has to be smaller than side FE, which is there in green. And so the inequality that they're wanting us to write, they're wanting us to say which side is bigger than the other. So if you'll remember your inequalities, this means less than, and this means greater than. So in this problem, we want to say that the blue CB is smaller than the green FE. So we could say that side CB is less than side FE. Now I'm going to work one problem from the section here in a second. I want you to pause the video once it's up and see if you can work it. Okay, so here's the problem. You can see here we've got two triangles that have shared side lengths. We can see that KE and QR have the same measure, and FE and SR have the same measure. The only thing that's changed is the angle between them. Right here I have a 60-degree angle, and here I have a 75-degree angle. So we know the side length opposite the 60-degree angle must be smaller than the side length opposite the 75-degree angle. And so we want to say then that 15 must be smaller than or less than 2x plus 3. So now this is an inequality, and we solve it just like an equation. So we're going to get x by itself by subtracting 3 from both sides. That's going to give me 12 is less than 2x. And now x is being multiplied by 2. So I'm going to divide by 2. That tells me x must be greater than 6. Right? So that would be our answer there. And you're going to have some that are similar to this in your homework. Okay, so here are the kind of more difficult problems, putting everything together. You can see we have 3 triangles that are all connected, and all 3 of these triangles have 2 sides that are the same length. You can see here how AC has a tick mark, CE has a tick mark, EG. So all those triangles are the same, or all those sides are the same length in those 3 triangles. Then we have BC and DE and EF all have 2 tick marks. So we've got triangles that share 2 side lengths, and we're wanting to find what are the possible value of x's dealing with those angles. So we can see here with the 60-degree angle, across from it is a side length of 21. Okay, let's look at the next triangle. In that triangle, we have an angle measure that is 2x minus 4 degrees, and across from it is 18. So we don't know a lot about the angle, but because side CD is less than side AB, then that means angle DEC has to be smaller than angle ACB. The blue angle must be smaller than the yellow angle because the blue side is smaller than the yellow side. So we could say then in math that that angle DEX, 2x minus 4, must be smaller than 60. Okay? But also, if I look at this triangle, I can see that my side length here is 14, and that angle is 36. So my unknown blue angle, which has a side of 18 opposite, is bigger than this green angle, because the green angle's opposite side is only 14. So because 14 is less than 18, then that means 36 degrees is smaller than 2x minus 4. So we could also say that 2x minus 4 must be bigger than 36 degrees. So the blue angle is smaller than the yellow angle, but the blue angle is bigger than the green angle. So I'm kind of narrowing in on what x must be. It must be something between these 2 inequalities. So we're going to solve both of them. So with this one we add 4. That tells me 2x must be less than 64. I divide by 2. That tells me that x has to be less than 32. So the x value must be smaller than 32. Now if I solve the other inequality, that tells me 2x must be greater than 40. I divide by 2. That tells me x must be bigger than 20. So x is larger than 20, but x is less than 32. So I've kind of found the possible values of x. They are values between 20 and 32. So here's a couple of them I want you to try on your own. So you can pause the video and see if you can do them. Okay, so these is a little bit simpler because there's only 2 triangles to compare. So when I look here, I have a 54-degree angle, and opposite it is a side length of 12. And then inside I have an angle. I don't know the measure. It's 4x minus 18, but I know that its opposite side length is 10. And so because of that, I could say that the blue angle must be bigger than the black angle. So I'm going to set up an inequality that says 4x minus 18 must be smaller, must be less than 54. Then when I solve, I'm going to add 18 to both sides. That tells me 4x must be less than 72. I could divide by 4. That tells me that the x value must be less than, and I'm doing this in my head, so I may miss it. It's going to be 32. Makes it 4, 32. Yeah. So my x value must be less than 18. Right, and that's all we know for sure. Okay, when I look at B part, if you haven't already worked it, go ahead and pause the video and try to work B. Now in this one, it's a little bit trickier because, look, we only have one known shared side. Do we know a second shared side of those triangles? We actually do, because they overlap here in the blue section. So I have the correct criteria. Have a triangle with two shared sides. And so when I look at the angles, I have 32 degrees, and across from 32 degrees is a side length of 16. And then here I have an angle that's 3x plus 5, and its side length is 21. So because the red side is bigger than the yellow side, that means the red angle must be bigger than the yellow angle. So I would say the red angle, 3x plus 5, must be greater than the yellow angle, which was 32. And now we solve. Subtract 5. That's going to give me 3x must be greater than 27. I divide by 3, which tells me x must be greater than 9. So that's going to be the last problem here from this section. So hopefully you took good notes. If this is Thursday, you're watching the video, you could go ahead and start working on the problems if you wanted to, because I know my 7th period, we're going to have a Zoom meeting today for you to ask questions on the homework. So it's probably good to go ahead and get started on that. For my 4th period and my 6th period, again, we'll work on the problems tomorrow during Zoom, but if you want to get a head start, the problem set should already be posted.